a diagrammatic representation of a set and also the properties of sets is called a Venn diagram. Union of the sets is represented like this. The shaded region will give the union of two sets, A union B. N of A minus B is equal to N of A minus N of A intersection B. N of B minus A is equal to N of B minus N of A intersection B. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding Venn diagram and the problems based on Venn diagram, how to construct a Venn diagram. Now, what is this Venn diagram? Venn diagrams, a diagrammatic representation of sets and properties of sets is called Venn diagram. A diagrammatic representation of a set and also the properties of sets is called a Venn diagram. So, in the name of the famous mathematician Venn, describe this Venn diagram. Okay. Now, let us consider how to construct a Venn diagram when the operations like union, intersection, difference, complement are given. First one, a set is represented by a circle or a closed figure. This is a, suppose if A and B are any two sets, a set can be represented by a circle like this or ellipse like this. Okay. Now, universal set. So, the rectangle will represent a universal set. Universal set is represented by the figure rectangle. Now, A union B. Suppose if A and B are any two sets, U is a union, then the shaded portion is A union B. All the elements which are in A and B, all the elements including A and B comes under the union. So, union of the sets is represented like this. The shaded region will give the union of two sets, A union B. The elements, that is, elements which are in A or in B. Now, let us come to the next one, intersection of two sets, A intersection B. So, what is the meaning of A intersection B? Usually in A intersection B, we are going to take the common elements. So, this shaded region will represent the intersection. So, the elements which are common to both A and B are represented here by the shaded region. This is the intersection of two sets, A intersection B. So, this is very important. The common region determined by these two sets, the common will be represented by the shaded portion will give the intersection of the two sets. Okay. Now, difference of two sets, A minus B. A minus B is, as you know, A minus B means elements which are in A but not in B. All the elements which are in A but not in B. So, the shaded region will give the elements of A minus B, the shaded portion. That means, these elements will represent A minus B, all the elements in A minus B. So, here this is A intersection B, the common elements. Here A minus B, all the elements which are in A but not in B. Now, similarly, if you come to B minus A, this is B minus A, all the elements which are in B minus A, that is, the shaded region represents the elements in B minus A, that is B minus A. Next one, the symmetric difference. The symmetric difference of A and B is denoted as A delta B, that is nothing but A minus B union B minus A is nothing but the shaded portion will give the symmetric difference, that is, these are the elements of A minus B and these are the elements of B minus A. The union of this, union of A minus B and B minus A is represented like this. This is the symmetric difference. So, that is symmetric difference is represented like this. Okay. Now, subset. The subset, a subset is represented like, suppose if A and B are any two sets, then A is a subset of B is represented like this. So, A is the subset of B. A is the subset of B. And A dash, the complement of this set, A dash or the complement of A is denoted as U minus A. All the elements which are in universal set minus A. All the elements other than A, this is a universal set. All the elements other than this A will give the complement of this denoted as A dash, that is A dash, A complement. This shaded region will give the A dash in U. This shaded region will give the complement A dash in this set U. Okay. U minus A, all the elements which are in U but not in A is represented by this shaded region. Okay. Now, disjoint set. two disjoint set. Disjoint set means their intersection is a null set. If there is no intersection is a null set means then they can be represented like this. So these two sets A and B are said to be disjoint set because the intersection of these two sets is a null set. This is how we are going to represent a set in a Venn diagram. List of formulas. So these formulas are very useful to solve the problems. The application type of problems can be solved with the help of these formulas, that is using n of A union B, n of A intersection B, n of A union B union C, or n of A intersection B intersection C. Now let me discuss those formulas. Suppose for any two sets, if A and B are any two finite sets, then n of A union B, number of elements in A union B is equal to n of A plus n of B minus n of A intersection B. The number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. So n of A union B is equal to n of A plus n of B minus n of A intersection B. Suppose if you want to interchange this, similarly n of A intersection B can also be written as n of A plus n of B minus this, transfer this n of A union becomes minus n of A union B. This is also one formula which is used to solve the problem. So n of number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. Similarly, number of elements in A intersection B is also equal to number of elements in A plus number of elements in B minus number of elements in A union B will give the intersection. These two formulas are very, very important to solve the problems. Now, suppose if A intersection B is equal to a null set, if it is a disjoint set, if A and B are disjoint set, if for disjoint sets the intersection is a null set, if A intersection B is equal to null set means then the number of elements are 0. N of A intersection B is equal to 0, then this becomes 0. N of A union B is equal to n of A plus n of B minus 0 can be written as n of A union B is equal to n of A plus n of B. That means number of elements in A plus number of elements in B is equal to number of elements in A union B for a disjoint set if A intersection B is equal to a null set. Now let us consider the same concept for three sets. If A, B, C are any three sets, if A, B, C are any three finite sets, then number of elements in A union B union C, n of A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C plus n of A intersection B intersection C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C. This is also a very, very important formula indeed. So number of elements in A union B union C is equal to n of A plus n of B plus n of C plus n of A intersection B intersection C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C. Now, suppose if A and A dash both are finite set, if a set and the complement of the set A are finite set, then number of elements in A dash, n of A dash is equal to number of elements in U minus number of elements in A, where U is the universal set. So, if A and A dash both are finite set, then the number of elements in A dash, the complement sets is given by n of U minus n of A. Number of elements in U minus number of elements in A will give us a number of elements in the complement set A dash. Okay. Based on this, let us take a simple problem. Before that, yes, let me take one more property. Now, if A and B are two finite set, for any two finite set A and B, the difference n of A minus B is equal to n of A minus n of A intersection B. So, if A and B are any two finite sets, then the number of elements in A minus B, n of A minus B is equal to n of A minus n of A intersection B. Similarly, n of B minus A is equal to n of B minus n of A intersection B. So, for any two sets A and B, the two finite sets, then n of A minus B is equal to n of A minus n of A intersection B. N of B minus A is equal to n of B minus n of A intersection B. Now, let us come to the problem. In a class of 50 students, 15 do not participate in any game and 25 play cricket and 25 football. find the number of students who play both. Now let us represent the number of students who play cricket as C. What is given? Write down the given condition. So if C represents the number of students who play cricket, N of C is equal to 25. So 25 students will play cricket, and the number of students who play football is N of F. N of F is equal to 20. Then number of students N of U is equal to 50. And what is to find? To find the number of students who play both in the sense number of students who play cricket intersection football is the question mark. Okay, this is the given condition. So in a class of 50 students, so 25 will play cricket, 20 will play football, and how many students will play both cricket as well as football? But one condition is given: 15 do not participate in any game. So 15 students are not participating either in cricket or football. So therefore the number of students who participated in the game is N of C union F is nothing but N of U minus 15. N of U is 50 minus 15, that's equal to 35. So therefore N of C union F is equal to 35. Okay. Now N of C union F is 35. Now what is required to find is intersection of F. So we know the formula, that is N of C union F is equal to N of C plus N of F minus N of C intersection F. So using this formula you can simplify this. Let me go to the next page. So since therefore the formula is N of C union F is equal to N of C plus N of F minus N of C intersection F. What is C union F? C union F is 35. 35 is equal to a number of students who play cricket is 25. Football is 20 minus N of C intersection F. So this is 35 is equal to 25 plus 20 is 45 minus N of C intersection F. Transfer this. Therefore, N of C intersection F is equal to 45 minus 30, that's equal to 10. So therefore the number of students who play both cricket and football is 10. This is how we are going to simplify. So this can be represented in a Venn diagram. The very easiest method to represent this in a Venn diagram. This is U is equal to 50. There are two sets, A and B. So cricket as well as football. Okay. So the number of students who do not participate in any game is 15 students. That is 50 minus 35. 50 minus 15. So 15 students are not participating. So what is remaining is 35. So here the number of students who play cricket. So the number of students who play cricket is 25. Number of students who play football is 20. Then the number of students who play both is 10. Right. So 10 students will play both cricket as well as football. The remaining, what is remaining here? So number of students who play football are 20. 20, already we have 10 here. 10 plus 10 is 20. And the number of students who play cricket is, already we have 10. So 10 plus 15 is 25. That's it. So this is how we are going to represent. So the number of students who do not play any game is 15. The number of students who play all the games, that is 15 plus 10 plus 10, that's equal to 35. 10 students will play both cricket as well as the football. Okay. So this is the intersection. This will represent number of students who play cricket intersection football. That's it. That's equal to 10. This is how we are going to represent in a Venn diagram also. Okay. Now this is how we are going to solve a practical problem in sets. That's all regarding today's session. Let us meet with different types of problems in this concept in the next class. Thank you. Thank you very much.